welcome everyone to the last session today. Last year we had a talk about the Harbor container registry, and during the conference we were chatting on our live platform live.siemens.io, and there I met one person from Exoscale, and we agreed upon, hey, join next year. And so the conversation started, and today we heard a lot about the hyperscalers across the world that many of us are using, but there are also other clouds. And I'm very happy that we have Pierre-Yves Ritschard here from Exoscale, CTO at Exoscale, presenting us of 10 years of building the cloud. Welcome, Pierre-Yves.
Thank you, Roger. Thank you. Hi, everyone. First of all, I'm extremely bummed. I can't join the crowd today. It's a bit of a last-minute thing. I was intended to be in Zug. I'll make sure that it happens come next year. If I don't bore you to death with my with my session, and I hope it's not too heavy to end the day today. So as Roger said, I'm a co-founder and CTO here at Exoscale. I'll spare a few words about what we do. Over the course of my professional career, I focused a lot on infrastructure matters, distributed systems, and quite a few digressions around monitoring as well. And I also have an extensive experience in various open source communities. I guess the most prominent one would be OpenBSD, a team which I'm not active in anymore, but with which I've worked over the course of several years to help release key kernel functionality around firewalling, around load balancing, and many other topics. But today, I'll try to shed a bit of light on, about how open source can help for a small nascent company, and how, as things evolved, a company can contribute back, and in which areas it can, and a few of the ways with which we approached this. So very briefly, we are an infrastructure as a service company. We are, everyone knows about the IBM of the world today, the huge hyperscalers. We fit in that nice area of tier 2 providers. We have a few unique colors. We're purely European, with zones in Germany, Switzerland, obviously, Austria, and Bulgaria. That's what we look like when people use the web portal, but most people who use Exoscale tend to go through automation tools, such as Terraform here. All right, what's this got to do with open source to begin with? Well, especially since, in the minds of everyone, building a cloud infrastructure platform entails mostly buying big boxes that you rack in data centers and slapping some virtualization layer on top of that. Turns out that a company like ourselves ends up building a lot of software internally. From very concrete matters such as the orchestration platform, but ranging from API gateways, web portals, the streaming platform with which data is metered and then billed and invoiced to customers. So tons of software to write, essentially. And as I was saying, back in 2012, when we decided to embark on this mission, we didn't have a lot of people around to build this. And last but not least, there's this notion in the infrastructure world that most things are, glue scripts tying the world together. creating an actual product proposition and going down the path of being an actual provider entails writing full-grown software. So the first obvious question is why go with open source to begin with, right? Why base Exoscale on this, especially since back in 2012, there were a few vendors willing to help nascent providers like ourselves go out to the market. VMware being the obvious one, but many others were willing to help. So we placed a bit of a bet, thinking that over time we would like the ability to quickly make changes at any position of our software stack with a short turnaround. If we were to find things that we wanted to solve in new ways, the ability to tailor the software that we would adopt to the specific needs the provider has, because a lot of the software you find out there is tends to cover many use cases, where as providers tend to want to optimize for their specific needs, which allows them to make shortcuts and be more efficient. And last but not least, all of the infrastructure world has a very long and fruitful relationship with open source. I mean, from Linux, obviously, I was mentioning OpenBSD in the security and network firewalling space, all the way to Apache, Nginx, and any web server that you use today tends to be open source. So with this, what I'll try to give is a bit of a rough timeline of the key milestones for open source at Exoscale, where we adopted, where we gave back, and basically how that helped us build our platform over time. So again, started with very little, and from there, we wanted to have a bit of a different product proposition that most local providers would give back in the day. So not necessarily something that would mimic an actual data center. Integration with automation tooling, which already back then tended to be very widely open source. Automation tooling in 2012 wasn't the same than today. Docker didn't exist, neither did Terraform. Almost feels as if TV didn't exist back then. When you look back, the tools of the trade were more Vagrant, Puppet, and things like these. So first things first, for the cloud orchestration platform, the project that tended to be the more mature back then was Apache Cloud Stack, which is the choice we made. It fit well our approach to software design and development. The Puppet configuration management tool ended up being a large player in our initial stack, as well as MySQL was again an open source solution. The two things we wrote ourselves from the get-go were customer management tooling to bill and invoice customers, as well as the web portal that we initially spun up. And I will say the more controversial choice we made right there and then was the one around monitoring. Instead of going for the obvious players, we went for Riemann, which is a bit of a special case. So apart from the monitoring space, extremely basic, it almost looks like a standard free tier deployment. We did happen to also procure hardware to run this whole thing on. and to start delivering to the local crowd in the Swiss French area. But as I was saying, we made these choices around monitoring. This early 2010 era was one where the monitoring world was, trying to rethink itself, and a lot of the existing solutions didn't fit the needs of evolving organizations anymore. Tools like Nagios or Zabbix didn't fit the mold of a world where nodes would be able to pop up and go away relatively often anymore. And Riemann, posing itself as a stream processing platform dedicated to monitoring, fit what we were trying to do extremely well and opened up new opportunities for early fault detection on the platform. And as a relatively new product, it was our first opportunity to step into the world of open source as Exoscale. Even though we had previous habits, we initially started submitting tons of fixes and quickly actually became co-maintainers of the tool with the original author. A bit of time goes past. We released our initial web portal, which reflected our ability to do design back then, which was very scarce. But we gathered a bit of local interest, and the few initial bets product-wise that we did worked out. But to continue evolving in a, let's say, a relatively agile manner, and to continue delivering new functionality fast to customers, we quickly faced the issue of release automation. So again, at this time, I think we're already 5 in the company, so still a very small group. As you can see on the diagram, it's still a pre-Docker world. So our production release artifacts were actually Debian packages back then, released on Ubuntu machines. And we had a relatively smooth pipeline to produce those artifacts. But what we wanted was a really seamless and low effort way to actually release to production, while keeping the promises that we made to customers that we would adhere to strict, to good production habits. So having a change admittance step before going to production. So we ended up building a small command and control platform with very few dependencies to limit the operational burden, which essentially controlled our production and staging nodes and helped us write scenarios that explained how a specific product needed to be released to either staging or production. This tool we wrote a UI for as well, and was our second relatively large open source experiment. And for the time, it brought a couple of things with it, such as mutual TLS for end-to-end security of release automation, IRC support, which is where we chat on a day-to-day basis, which allowed us to control command and control from our chat environment, and it also helped shape the way we think about orchestration, and also help prefigure some of the approaches we took for the later on. So we reached a point where our local crowd was happy with the service we provided, mostly VM focused, with snapshots, with security groups, with a few things, but we still relied heavily on local storage, which doesn't fit all use cases, right? So we set our sight on building an object storage platform because it was the obvious complement to the local storage volumes we exposed. Architecturally, slightly simpler than distributed network block devices, and yeah, ended up fitting well with the crowd we had. Unfortunately, the object storage world is one where open source did not win. The AWS S3 more or less ate the whole market. So the only thing you could do as a provider was to expose the S3 API directly. We had a look at vendor-backed solutions, which at the time were few and far between. A couple of open source solutions existed as well, but were relatively limited in what they could do, or didn't expose the S3 API. So we started looking at what it would mean to write one, and with a few compromises in mind for the initial release, and there was a bit of semi-academic literature around how you go around building that out in the wild. So we initially chose Apache Cassandra, again an open source solution, as the foundational piece for writing that system. It's a system that the early joiners at Exoscale had previous experience with. We were very well integrated in the open source development community of Apache Cassandra. And it could help us get off the ground relatively fast. So we decided to build it this way, thinking that it would be essentially a walk in the park. But a few things ended up being harder than anticipated. Mostly the fact that not coming from a community, but being solely owned by a provider, the S3 API is not the easiest or not the best specified protocol you'll ever find. Let's say it like this. I mean, typically, even down to how the API works, there's a lot of quirks in the way requests that look extremely similar can end up in widely different commands having to be performed. And the sheer volume that you end up storing on S3 like systems comes with its own sets of challenges. As a quick anecdote here, we had a relatively smooth start on the platform up until CERN came around and started using Exoscale, and they prove extremely apt at finding the limits of our platform. But I'll spare a few more words on this afterward. And the result of our early experiment we released as open source, and the platform with which we started providing S3 compatibility is still hosted on our GitHub. Then 2015, we from a product perspective, we were still on a trajectory where we were slowly evolving and adding to the product. But we started seeing a few things on our base platform that showed growing pains. Essentially, having more and more customers meant producing more and more metrics. We added tons of new capacity, but with new products, there were also new data points that we needed to watch out for, and we reached the limit of the what people call the ERG stack. Elasticsearch, Logstash, and Kibana. A few of those were from the nature of the stack, at least as it was in 2015. First of all, Logstash was a relatively heavy workload, and installing it on each and every one of our compute nodes, especially since the Exoscale compute nodes start at 512 megabytes of RAM, ended up taking a large proportion of that for the very, very small ones. Going directly to Elastic tied us to the availability of Elasticsearch, which at the time wasn't always the best. So we looked for a way to have a smaller operational burden on nodes and have more resilience whenever Elastic would have issues. So again, we turned to open source. We looked at what we had available to log, with syslog-ng being available on all of our nodes, as well as collect-day. And in other parts of our infrastructure, we relied on Apache Kafka. And the thought that set off was that we could use Apache Kafka as a large throughput platform to ship all of our logs and metrics to, and that we would then consume from Apache Kafka topics to produce Elasticsearch indexes and also store metrics. The only flaw in that approach is that neither syslog-ng nor collect-d knew how to produce data to Apache Kafka. So and that's a bit the beauty of open source in a way. We wrote support for Apache Kafka in syslog-ng, and so did we for collect-d, which ended up being heavily used plugins throughout the community. We also kept on improving collect-d to help disaggregate the work that we would do, and to ensure that most of the work it could do locally on a node, it would. To give you a brief example, to ensure that the CPU averages, instead of producing raw value, would be smoothed to the amount of CPUs, because those tended to be computations we would do at a central location previously, and it's way more efficient to ensure that is distributed across the whole fleet of nodes who produce metrics. After this, we hit the stage where CERN, pounding heavily on our object storage platform, showed the limits of Apache Cassandra as the only substrate on which to build the object storage platform. And we set out to try to see how we could evolve that platform. This materialized with extremely large tail latencies for some of the use cases that the platform was used for, and there clearly wasn't a way forward with just Apache Cassandra. On top of this, a ton of new API capabilities spun up is in the S3 world, and as I was saying, as a non-specified protocol, these are things that you discover when new use cases come around. And a particular piece of software in the open source figured out really smart ways to use all of the S3 capacities in widely different ways. Which is the Docker registry, which ended up being a great test bed for our compatibility with the protocol. So here, beyond open source, we found an academic paper that came with a semi-open source solution from the LinkedIn team, which described an approach that tended to fit the bill for what we would want to do in the object storage space. So we set out to write something inspired by the paper. We took a few key decisions as we built that around how to actually store the blobs of data, how to perform the orchestration and chunking of object storage data, as well as how to deal with metadata. So we kept as much as we could from the previous system, and we replaced parts of it with more efficient solutions. Again, a ton of UI work went into the system as well to ensure that the operational burden would keep relatively small. And here, it's while it's a system that's in production and has been serving us very nicely, and underwent a number more changes. The open source status were not quite there yet in our path to open source it, but that is something that we intend to do in the relative near future. For these lighthouse projects, we do. Open sourcing takes a bit of an effort in terms of preparing the release and ensuring that there's documentation around what we do, because otherwise it's relatively useless. So that effort we do in batches and hasn't gone through just yet. 2018 ended up being a bit of a weird year of sorts. First of all, because the world of cloud infrastructure providers went through a bit of a crisis early in the year with Spectre and Meltdown, if you remember. But it also showed the strength of communities revolving around open source software, because very early on, with different other providers, we were able to establish direct communication channels, and here relying on vanilla open source, so not heavily modified versions of kernels, and having pushed our changes upstream every opportunity we could, really helped with the turnaround we were able to have in terms of the integration of the mitigating patches for Spectre and Meltdown. Another large choice related to open source we made at that point was to bet on Kubernetes. As you may have seen from different pieces, there were a ton of Apache projects co-opted by Exoscale. So as a good Apache ecosystem members, we had placed a bet on Apache Mesos as the one who could win the container orchestration wars. Turns out it didn't, and Kubernetes did. So we, 2018 is a year where we really started investing in understanding it inside out to be able later on to produce a stable managed Kubernetes offering. In terms of open source, though, very early on, we started contributing back to ensure that things would work well with Exoscale. Today, we release a number of functionality directly upstream, such as the autoscaler, the cloud controller manager, external DNS support for our managed DNS API as well. These things are all directly available upstream, and we interact with the Kubernetes community on a regular basis for this. And this week is actually KubeCon, and we have several members of the team present there. And I mean, to round out a bit this small detours through the things we do with open source. In 2019, as we set out to build the managed Kubernetes orchestration platform, we also decided to rethink the core orchestration facilities that we have. This came on the back of our releases of the instance pool orchestrator, but we also released a network load balancer orchestrator. We were building this managed Kubernetes offering, and it's the life of Exoscale to incrementally release products that rely on orchestration. So a couple of steps removed, orchestrations sounds relatively simple. It needs a data layer access facility to be able to store configuration. The fact that customer A wants 10 virtual machine instances. A common way to approach managing the need for orchestration is to rely on finite state machines to have a reliable way to ensure that all different ways with which the state of a particular entity can evolve leads to an actual action. And then every infrastructure automation or every infrastructure company ends up having relatively specific needs in the area of workflow engines. So, whenever configuration or the state of the world change, you try and understand what needs to be done to reconverge to the expected state, and the result is a workflow to perform side effects to try and converge. So here we designed a platform to help us build this orchestrator in a relatively fast and safe manner, and we released 3 key libraries around the spaces I just described. One to implement our flexible data access layer, which gives us a fast and efficient way to interact with the underlying storage, which holds configuration for the expected state of the world. A finite state machine library, which specializes in the particular state machines that are the most efficient at implementing things for orchestration needs. And again, with a small UI to ensure that you can safely test state transitions. And last but not least, a full-blown workflow engine, which allows us to quickly produce programs that can span a relatively long time, and that can also provide helpful visualization into the output to have the ability to, when a relatively large side effect workflow was performed, to understand if something goes wrong, what went wrong, and to be able to quickly pinpoint and recover. And that concludes the rough tour I wanted to do. A quick word on going from 3 people to a 50 people engineering team now, and a nearly 100 people company. Open source plays a very large part into how we stood up the platform, and the initial bets we made around having the ability to quickly make changes at any point of the stack. This truly paid off and helped us also understand from A to Z the core functionality that we do, building this intellectual property internally, integrating the communities for the open source software we rely on, really helps the whole engineering team become expert at the things we host for customers. For some things we have a high dependence on open source databases and some key low-level components such as the Linux kernel, but also libvirt and QEMU. We closely follow releases and help in the ways we can, but those are solid, established components that a middleware layer is where we have a huge part to play in the open source communities as well. As I described over the course of the talk, we have several lighthouse projects, our object storage platform, our CLI, which is also open source. We've got several Apache project members on board in the company, as well as key contributors to major projects, from the monitoring ecosystem to programming language communities. I showed the core libraries that we published, but there are many more that we regularly publish, and we also have a dedicated team that helps us make sure that automation tooling, such as the ones provided by HashiCorp, Terraform, Packer, Vault, and more, work seamlessly with Exoscale. So there's also a large open source involvement here. And because we're engineers and we love process and documentation, the ways with which we participate, the fact that open source is encouraged at Exoscale is even something that you find in our internal onboarding documentation. That's how serious we take this. And with this, that's all I had for today. I'm a bit bummed I couldn't see the audience because it's hard to understand whether I'm losing you or not, and whether I should stress a few things or not. But happy to take questions if there are any. Thank you.
Thanks a lot, Pierre-Yves. Impressive to see a company of the size you are contributing so much to open source projects, maintaining open source project, not only for the infrastructure purpose, but also providing like the Terraform providers and so on to really enable the customers. I've never seen a similar company that is so committed to open source. Thanks a lot for this. And I have one question. Do you have numbers? How many of the so-called clicky customers versus the API only customers? What's the distribution on your customer end?
I don't think the numbers show a good picture because the API customers tend to use both. What we've seen, and we actually ran a few surveys on this as well, is that I'd say for visualization purposes, like getting a quick idea of the thing that I wrote out in my Terraform modules producing the expected results. You still tend to go to the web portal. So it's heavily used as a visualization / read-only type console to understand whether the results of what's being performed with the infrastructure as code tooling works as expected. So I guess my characterization in the early slides is a bit misleading in that respect. I would say the main vessel of change to the infrastructure tends to be automation tooling. For our key customer segment, which are customers that are used to automation tools. We do have, also the odd customer who wants to manage their own private infrastructure on Exoscale for their own website or small machines, and then it tends to be GUI-based access for these use cases.
Thanks a lot.
Any questions here from the local audience? Yep, there is one.
I mean, this is both a question and a suggestion. You know, I saw in your presentation that you seem to have been doing really cool things upstream. You know, like with the autoscaler for Kubernetes. So I mean, those are significant contributions, and you didn't really got deep into that. I mean, I would have loved to see a bit more of that, actually. You know, like the actual upstream process. So, maybe you want to elaborate a bit now about that, but how the trip was, or if you found issues. But that's a really cool thing.
So it's a very selfish approach, to be honest, because it pays dividend for Exoscale. So I'll share the story. I'll share is one of the things we try to do is to be first, right? So when something significant comes out, which has provider infrastructure as a service provider support, we really try to move fast. I guess the most salient example here was Docker machine. Docker machine came out, I can't remember exactly, I guess 2016, 2015, something like this. Docker was already at that point on a relatively fast-growing curve. It had Gartner a ton of interest, but there remained this question of is this something I can use for production or not? Right? That still remained an open question back then. And Docker's initial try in this space was called Docker machine, which allowed you to say Docker machine create, and then to use the created machine to push. We were the first. Seeing that pop up, we pushed hard to very quickly develop the integration facility for Docker machine on Exoscale, and we eventually had the first pull request up in that repository, which allowed us to be fully integrated in Docker machine, which ended up being a benefit for Docker users, but also for us, because referrals coming in from the Docker documentation website ended up being the top access to our website for a relatively long amount of time, in the amount of a couple of months. And in terms of the upstream process, it's, I would say, relatively straightforward. We tend to observe, the expected the expectations of projects, be they Docker, Kubernetes, or else, in terms of what the patches should look like, what goes into what the expectations are for something to be easily merged. We try to adhere to these standards and work through the community in GitHub PRs most of the time directly.
Awesome. So Sally, we only have time for one last question. Is there? I think there is one, yeah.
Ouais, merci pour la présentation. I have just one question, and can you shine like in 2 sentences why did you not choose MinIO or Ceph's object storage implementation? I mean, you elaborated a little bit, but you didn't shine light towards MinIO, for example. And that would be
MinIO largely. MinIO is a simple answer. It didn't exist when we released SOS. Ceph did, but had a huge flaw in the S3 implementation. It funneled all access to the objects. I mean, back when we started working on the object storage platform, the object storage gateway was very much an afterthought and had a large number of performance issues, which actually DigitalOcean are still battling because they chose Ceph, and another competitor in Europe went away from for very much the same reasons. So it's mostly architecture-wise, sorry, it wasn't the best fit. There's a more social reason we didn't choose, and we chose to build that knowledge internally. It's to be on. It's harder in that space to adopt software than to produce it and to because infrastructure is a long game, right? The bet you make today, you pay. If you make the wrong one, you still pay 10 years later. So we want to be on top of the technology that we produce and host.
Ouais, merci beaucoup. Couldn't agree more.
Fantastic. Thank you so much, Pierre-Yves, for giving us such deep insights into how you're using and contributing to open source software. Impressive. And I hope you're going to see us next year here. And I wish you a very nice evening. Thanks a lot.
Hope so as well. Have a great barbecue. And yeah, I'll try and be there next year. Cheers.